Okay, so let's have a look at this question. We've got a band of 100 gorillas is being introduced to the wild, and the gorilla population is expected to increase by 4% each year. We're being asked here to write an algebraic expression that represents the gorilla's population, P of t, with respect to time in t years. Well, to do that, let's just remind ourselves of the basic exponential growth expression and what those values represent in it. So the basic exponential growth expression is y equals a times b to the power of x, where our a value is going to be the starting value, or the initial value, in this case the initial population, and the b is going to be the common ratio. Now, to find a, well, that's quite easily because the initial population's being given to us in this question. It's 100 gorillas. So the value of our a is going to be equal to 100. So all I really need to find is this value of b now. And to find the value of b, what we actually got to do is look at whether it's growing or decaying. In this case, it's growing. It's increasing each year, which means that we're going to have 100% plus an extra 4% each year. So that will end up being 104%. But of course, when we put this into the equation itself, we need to represent it as a decimal. So that'll be equal to 1.04 when it goes into the function. So what we can now do here is we can represent the population of the gorillas with respect to time by stating that our population with respect to time is equal to our initial value, so those 100 gorillas, multiplied by the common ratio of 1.04 to the power of t, with t being time in years. Now, you might be wondering, why might we want to do this? Well, if we can find a function that represents the population over time, we can use this function to find the population after a given time, or even the other way around. We can find how long it's going to take for the population to reach a certain amount. So let's do one of those. Let's say we wanted to know what the population is after 5 years. Well, to find that, what we're really looking for is when t is equal to 5. So we're finding the population when t, or our input into this function, is equal to 5. So this is just substitution. This will be 100 times 1.04 to the power of 5. And if we go and put that in our calculator now, we will find that we will have approximately 122. And of course, this is a population, it's the number of gorillas, so we'll have 122 gorillas. So, in summary, if we know the initial value and can work out the common ratio of an exponential growth or decay function, we can represent a function in this format here.